show that the function t of x comma y equal to xy x into y comma x plus y is linear. Two elements, and here we have two terms, so function r square to r square. So here let us consider u is, here x and y is there, so we write it as x1 comma y1, and v is x2 comma y2. Now we add these two, so we add x1 plus x2 term, and y term is nothing but y1 plus y2. So substitute this one in the given function, that is t of u plus v is nothing but t of x1 plus x2 comma y1 plus y2. So here we have the function x into y is there, x is nothing but x1 plus x2 into y, y is nothing but y1 plus y2, comma x plus y is there, x is x1 plus x2 plus y is y1 plus y2. Now we multiply this one, and we see that we can write it as x1 into y1. So here if we multiply, we can write it as x1 into y1 plus x1 into y2 plus x2 into y1 plus x2 into y2, comma here we can split the term, we can write it as x1 plus y1 plus x2 plus y2. So here first term is there, we cannot split the term. Here we check with the right hand side, let us consider this as 1. So here we find t of u. So t of u equal to, we must substitute in the question, u is x1 comma y1, u is x1 comma y1, so we substitute in the given function, that is x1 into y1 comma x1 plus y1, and t of v can be written as t of x2 comma y2 can be written as x2 into y2 comma x2 plus y2. If we add these two, t of u plus t of v equal to, so if we add this one, we can write it as x1 y1 comma x1 plus y1 added with x2 into y2 comma x2 plus y2. So here if we add, we get x1 y1 plus x2 y2 comma x1 plus y1 plus x2 plus y2. So here we can check the first term in the equation number 1 and first term in the equation number 2 is not equal. So here x1 y1 plus x1 y2 plus x2 y1 plus x2 y2 is not equal to x1 y1 plus x2 y2. So here this one is not equal, hence we say that t is not linear. Whereas we can say that the second term satisfies, but the first term is not satisfied, hence t is not linear. Show that t of x comma y equal to y square comma x. So here we can add z also. So here we add one more term, x comma y comma z equal to y square comma x is there. We must show that this one is linear. So here we have three elements here, x comma y comma z, but here we have only two terms. So r cube tends to r square. So here we consider u x1 comma y1 comma z1, v is x2 comma y2 comma z2. Then u plus v, we add these two, we get x1 plus x2 comma y1 plus y2 comma z1 plus z2. Now we find t of u. So t of u is what? T of x1 comma y1 comma z1. We substitute these values in the given function. It is nothing but y1 square comma x1. So right hand side z is not there, no problem, and t of v is t of x2 comma y2 comma z2 equal to, if we substitute in the given function, we can write it as y2 square comma x2. So here left hand side three terms are there, right hand side we have only two terms. Not necessary that we must have all the three elements in the right hand side. Now we add these two, t of u plus t of v. So if we add this one, we can write it as y1 square plus y2 square comma x1 plus x2. So let us consider this as equation number 1. So here t of u plus v, so it is nothing but t of x1 plus x2 comma y1 plus y2 comma z1 plus z2. So we have the function y square comma x is there. So here y square is nothing but y1 plus y2 whole square comma x is x1 plus x2. This is equation number 2. So here we can see that t of u plus v should be equal to t of u plus t of v. Here the first term and here first term, we can see that y1 plus y2 whole square, we must check that this is equal to y1 square plus y2 square. So this is not possible, this is not equal, hence t is not linear.